Hello, geometry students. Mr. Zacek back and better than ever. Hey, we're on our final lesson of the year. We'll revisit some review things, but this is our last lesson. We're going to look at modeling and density. Okay. Now, the formatting of this is a little funky. I'm going to skip around, and density is this is a big topic. The questions are pretty in depth with it, so we're going to have to take our time working through these. So let's talk about density for a minute. Density is the amount of matter that an object has in a given unit of volume. The density of an object is calculated by dividing its mass by its volume. So this formula is need to know formula. So density is mass divided by volume. So we use weight and mass synonymously, however they're not the same. All right, in our problems we will use them as though they are. The mass of an object never changes, but its weight can change. So the classic example is if you were to weigh yourself on the moon versus on the earth, you'd be much lighter on the moon because of gravity, but you would have the same density. Okay, so again, the formula for density is mass divided by volume. So we're going to jump here to this question here, which is number 3. This will be the first one we do. And this one's pretty in depth. So let's read together. New streetlights will be installed along a section of the highway. The posts for the streetlights will be 7.5 meters tall and made of aluminum. The city can choose to buy the posts shaped like cylinders or the posts shaped like rectangular prisms. The cylindrical posts have a hollow core with aluminum 2.5 centimeters thick and an outer diameter of 53.4 centimeters. The rectangular prism posts have a hollow core with aluminum 2.5 centimeters thick and a square base that measures 40 centimeters on each side. So the density of aluminum is 2.7 grams per centimeter cube, and the cost of aluminum is 0.38 per kilogram. If all posts must be the same shape, which post design will cost the town less? How much money will be saved per street light post with the less expensive design? Okay, so we have this formula that density equals the mass divided by the volume. What we don't know, we know the cost. This is the mass over here, how much it is per kilogram. But what we don't know is, and we know the density, we don't know the mass of each of these objects, but we can calculate the volume. So the volume in and of itself is a kind of an interesting question because in the cylinder, it's a hollow cylinder. So meaning that when you have a post, it's not a solid core post. So whenever you have these hollow volume questions, we have to subtract in order to find the volume of the aluminum. So let's look at these dimensions. So it says it's going to be 7.5 meters high, and the cylindrical post, this is 2.5. So if we're just to look at the base of this, just to look at the circle, okay, on each side we're going to have 2.5 centimeters of aluminum. So that means, and then it says the whole diameter of the outer one would be 53.4. Okay, so that means this inner circle inside of here, so the outer one, the outer diameter is 53.4. That means that the outer radius would be that divided by 2. So if we look at 53.4 divided by 2 would be 26.7. So the outer radius would be 26.7. So then the inner diameter, because this we're going to have to subtract out this kind of internal space in here, would be 53.4 minus 5, which would be 48.4. And so therefore the inner radius, if we take that 48.4 and we divide it by 2, that would be 24.2 would be the inner radius. So to get the volume of the cylinder, that is where the part is aluminum, we're going to do, so the volume is going to be pi r squared h minus pi r squared h. So the radius for the outer one, 26.7 squared, and our height is 7.5, minus pi times 24.2 squared times 7.5. So this is going to give us the volume for that cylinder. Okay, so 26.7. So we've got pi times 26.7 squared times 7.5. Okay, that whole thing minus pi times, I gotta just look back here, 24.2 squared times 7.5. And we get 2,998.26. So 2,900, what was it again? 98.26. And this dimension is centimeters. What did I do wrong? They make this question even trickier because of what? I just looked back. This is 7.5 meters. So in order to put this in the same units, we would have to multiply. There's 100 centimeters, so this would be 750. So in this, we should have put 750 and 750. Okay, and if you figured that out before me and you've been yelling at me, good for you. Okay, you got the right thing. I think there's a way that we can go back up here and edit this. That will make our lives a little easier. Okay, can I do that? Enter. Can I come back up here and change this, or do I have to do it over again? All right, I think I got to do this over again. Okay, so pi times 26.7 squared times 750 minus pi times 24.2 squared times 750. Okay, so 299,826. Okay, 299,826 cubic centimeters. All right, now that's the volume. So how do we take the volume and figure out the mass? So if we know what the volume is, the density of aluminum is 2.7. So 2.7 equals the mass divided by this number. So if we cross multiply, that will give us the mass of aluminum in grams. So we'll just take that number here and multiply it by 2.7. So that's 809,530 grams. So this would be 809,530 grams. Okay. Now, the price for the aluminum is per kilogram. So if I want to figure out how many kilograms there are, kilo is 1,000. So I take that number and I divide it by 1,000. So the mass of the cylindrical poles is going to equal, so we take that number and we divide it by 1,000, which is the same as moving the decimal point 3 places to the left, so 809.53. So 809.53 kilograms. So we're going to take that now, the cost will be that number times 0.38 because it costs 38 cents a kilogram. So times 0.38 is $307.62. So this cost would be $307.62. All right, now we need to do the same thing for the rectangular prism. The rectangular prism also has a hollow core, but this one has a square base. So the square here is in the base, and it's 40 centimeters on each side. And so it's 2.5, so this internal one, we're going to subtract 5 from this. This would be 35 centimeters across. So the volume calculation for this is a little bit easier. I'll do a different color, green here. So this is going to be, the volume here will be the length of the outer one, 40. Now it says it's square, so 40 by 40 by 750. 750 is the height. So this is length times width times height. The inner one is going to be 35 times 750. Again, that's the length, the width, and the height. So again, the height here was the same. And we're subtracting because it has a hollow core, so 750 centimeters. So let's go ahead and do that. So we have 40 squared times 750 minus 35 squared times 750, and that is 281,250. So 281,850 cubic centimeters. So now we're going to do that same proportion that we did so to find the mass. So 2.7 equals the mass divided by 281,850. So I'm going to take that, I'm going to kind of do two steps in one. I'm going to multiply that and then I'm going to divide it by 1,000 to convert it to kilograms. So we take that number times 2.7, okay, and then we divide it by 1,000. So we get 759.375. All right, so 759.375. So the mass is 759.375 kilograms. And so now we know the cost of a kilogram is 0.38, so we're going to multiply that by 0.38, okay, times 0.38, 288.56. Okay, so the cost here is going to be 288.56. So, which post design will cost the town less? It would be the rectangular one, and the difference between those two would be the savings that we have there. And so I think we could easily get that. Okay, that's an intense question, all right, and I definitely should have left more space for that kind of question, but you get kind of the idea here of what we have. So we have sort of a challenging volume question because we have hollow cores. We have some conversions that we have to do. We have to apply this density equals mass times volume. We find the mass so we can determine the price, okay, and then we compare the price. So a lot of stuff happening in that one. All right, let's do one more here with this, and then we'll look at a population density question. So Walter wants to make 100 candles in the shape of a cone for his new candle business. The mold shown below will be used to make the candles. Each mold will have a height of 8 inches and a diameter of 3 inches. To the nearest cubic inch, what will the total volume of 100 candles be? So Walter wants to make 100 candles in the shape of a cone for his new candle business. The mold will be used to make the candles. Each mold has a height of 8 inches and a diameter of 3 inches. Okay, now the candle itself is simply the cone. So let's not get confused by the cylinder. So 8 inches, we got a 3-inch diameter. So for the volume of a cone, it's 1/3 pi r squared h. So the diameter is 3, the radius is 1.5, and the height is 8. So we would do 1/3 pi times 1.5 squared times 8. And that will be, to the nearest cubic inch, that will give us the volume of one cone. So the volume of a cone here is going to be 1/3 pi times 1.5 squared times 8. So 18.8496. 18.8496. Now this question says for 100 candles. So if we take 18.8496, the volume of 1, and we multiply that by 100, we're going to move the decimal point 2 places. 84 point, and this says to the nearest cubic inch, so that means we should round this 4 up to a 5. Okay, cubic inches. So Walter goes to a hobby store to buy wax for his candles. The wax costs 10 cents per ounce. If the weight of the wax is 52 cents per ounce inch, how much will it cost Walter to buy the wax for 100 candles? Okay, so Walter goes to a hobby store to buy wax for his candles. The wax cost per ounce. If the weight of the wax is 52 ounces per cubic inch, so we know the weight, so this is our density question. So density equals mass over volume. We're trying to figure out how many ounces, do we need the density here? So Walter goes to the hobby store to buy wax for his candles. The wax costs 10 cents per ounce. If the weight of wax is 52 0.52 ounces per cubic inch, how much will it cost? So we don't need the density formula here. We know that it's 0.52 ounces per cubic inch. So we know the volume now. So if we're going to multiply 0.52 times 1885, that will give us the number of ounces that we need that we'll have to buy. So we take 1885 times 0.52. So that would be 980.2. So we're going to need 980.2 ounces. Now, it cost 10 cents per ounce. So we multiply that times 0.1. And it's going to cost $98.02 for the wax. If Walter spends a total of $37.83 for the molds and charges $1.95 for each candle, what is Walter's profit? Okay, so profit equals, there's a little profit formula. Profit equals revenue minus expenses. So his profit would be, if he has 100 candles times $1.95, his revenue, the amount of money that he brings in, minus what he spent for the molds, $37.83, minus how much it cost for the wax. So this would be 195 minus 37.83 minus 98.02. So 195 minus 37.83 minus 98.02 would be $59.15. So that would be his profit on his business. Very simple calculation. Good to do if you want to start a business. Find out, are you actually making any money? So the money coming in versus the money going out. All right, so a modeling question here. Didn't have to use the density formula, but still some of these same kind of concepts that we've got going on. Let's look at, I want to do a population density one. Here's where I should have done that question because I actually have more room to do it. Again, I'm sorry. So in other situations that involve area or volume, besides mass per unit volume, population density of a region is the population per unit of area. So we could ask a population density, it's the population divided by the area. So let's do this question here. Burlington, Vermont has an area of approximately 160 kilometers squared and a population of 109,000 people. What is the approximate population density round to the nearest person per square mile? So population density, this one's pretty straightforward. It's 109,000 people divided by the area. 100, not 106, 160. Whoops, come back. 160. So people per kilometer squared. Whenever it's per, it means divided by. So 109,000 divided by 160 is, I'm just going to put that as a decimal, 68.125. 125, so we would say 68 people per kilometer squared. All right. So in this one, here you have to find the area. So the island of Puerto Rico has a population of 3,548,000. The island of Puerto Rico can be modeled as a rectangle. Find the approximate. So this is an estimation. So again, for a rectangle, area is length times width. So the area would be 106 times 37. Okay, 106 times 37 is 3,922 square miles. And so the population density would be the number of people divided by the area. So 3,548,000 divided by 3,922 is, let's put it here, 904.64 to the nearest person, so 905 persons per square mile. All right, so your assignment has some of these kind of challenging density questions, so we're going to have to work through this and anticipate that you'll have some questions to ask and some things to think through as we put this kind of stuff in our toolbox, this kind of combination of volume and density and area here. All right, this is the last one, so it's a little bit of a tricky one, but you can do it, and I'll see you back here as we do some review coming up.